Assalamualaikum warahmatullahi wabarakatuh. I would like to present my research with the title Analysis of Nickel and Chrome Plating Temperature on Corrosion Rate of Steel in Seawater Environment. Corrosion is the slow deterioration of materials, most commonly metals. This process can significantly affect the functionality and lifespan of metal structure and components. Materials that can expedite a material corrosion, including acidic rain, seawater, and salt. Applying surface treatment is essential for enhancing the material's ability to resist the corrosion. The surface treatment method that involves applying a metallic covering of nickel and then chrome to metal object. The nickel layer is applied to enhance adhesion strength and establish a uniform surface, while chrome plating enhances corrosion resistance and achieve a desirable aesthetic appearance. This study utilized ST14 steel, which is categorized as a low carbon steel due to its carbon content is only for about 0.106%. Then table here is shown the chemical composition of the ST40 steel. The Fa is for about 99% and the others is Se, Mn, SCr, and Al. The nickel plating procedure involves applying a layer of nickel onto the surface of the specimen for various time interval, 10 minutes and 30 minutes. Besides that, the process also involves a temperature setting of 40 degrees Celsius and a voltage of 5 volts. As for the chrome plating process, the specimen were exposed to different solution temperature at 23.3 degrees Celsius and 40 degrees Celsius with a processing time of 5 seconds each and a voltage of 5 volts. This process aims to identify the optimal condition for achieving maximum corrosion resistance and surface finish. The corrosion testing was conducted using electrolysis, employing a 3-electrode shell, which the name potentiostat PGS201T. Prepared specimens were positioned within the electrochemical cell, fully immersed in seawater and connected to the potentiostat. The potential was varied from minus 2000 millivolt to 2000 millivolt at scanning rate of 20 millivolt per minute to measure the intensity of the corrosion current. The corrosion tests were performed using saltwater samples collected from two beaches in Indonesia. The NaCl concentration in the seawater samples from Semarang and from Pandan Simo Beach were the concentration is 2.98% and 3.18% concentration of NaCl. And here is the result. The picture here depicts the thickness of the nickel layer acquired via the plating procedure. The result suggests that the plating process duration directly correlates with the thickness of the nickel plating. For 10 minutes of processing time, the thickness of nickel is 42.6 micrometer, and for 30 minutes of processing time, the thickness increases become 77.8 micrometer. And then the picture shown the thickness of the chrome layer acquired via the plating procedure at two different temperatures from 23.3 degrees Celsius and 40 degrees Celsius. And here are the corrosion test results. The following table 3 provides a concise summary of the corrosion testing finding for ST40 steel specimen, both with the and without chrome plating when submerged in seawater with varying NaCl concentration. The result suggests that the ST40 steel without any protective plating experienced increased corrosion rates when exposed to seawater with higher concentration of NaCl. The corrosion test results show that the smallest corrosion rate measuring is this 0.172 millimeter per year is obtained at 40 degrees Celsius chrome plating. That is the best result of the research. And here is the conclusion. The first is nickel chrome plating has improved the corrosion resistance of the ST40 steel. And then the optimal nickel plating duration is in 30 minutes, which yield plating thickness of 77.8 micrometer. And then the smallest corrosion rate is given by the temperature of 40 degrees Celsius in chrome plating. That is 0.172 millimeter per year. And the last is I would say thank you to all parties that has helped this research. And wassalamualaikum warahmatullahi wabarakatuh.